Hello student, welcome to lesson number 7, which is our last lesson. In this one, we are going to look at numerical problems on capacitors. So we start with the first example here, or the first question. A circuit is arranged as shown below. We have it 4 microfarads, 4 microfarads, then 5 microfarads, and 1 microfarad. Determine the total capacitance. And number 2, the total charge. We proceed as follows. First of all, we consider this one that is in parallel. 1 microfarads and 5 microfarads are in parallel. So you get our capacitance here will be 1 microfarads plus 5 microfarads, you get 6 microfarads. But now, these 6 microfarads is in series with these first 4 microfarads. So it will be 1 over CT is equals to 1 over 4 microfarads plus 1 over 6 microfarads. You get the effective as, remember now you have to add, the LCM is 12, 12 divided by 4 is 3, 12 divided by 6 is 2, you get 5 over 12. Now CT will be now the reciprocal, which is 12 over 5. You get that the capacitance is 2.5. Now the 2.5 is now in this part. We have combined this and this one. But now if you look at it, it is in parallel with 4 microfarads, which is here. So again, you add directly because they are in parallel. You get that the effective capacitance will be 6.4 microfarads. Then after getting the total capacitance, we need now to get the total charge. And the charge is always given by CT multiplied by V. Our CT is, or C is 6.4 times 10 to the power negative 6 farads. Then our V is 10 volts. You multiply and get that it is 6.4 times 10 to the power negative 5 coulombs. That is the charge that is applied by this network. From there, we have second question. 3 capacitors of capacitance 3 microfarads, 4 microfarads, and 5 microfarads are arranged as shown in the figure below, with a 10 volts battery across it. Calculate the charge stored in the 5 microfarads. We have it here. So first of all, the first step is to get the effective capacitance. So for the parallel, these two, we can be able to add them directly because they are in parallel. 5 microfarads plus 4, you get 9 microfarads. Then by adding these 9 microfarads now will be in series with these 3. So the effective now will be 1 over CT is equals to 1 over 3 microfarads plus 1 over 9 microfarads. You get now the effective is, the LCM is 9. 9 divided by 3 is 1. 9 divided by 9 is 9 divided by 3 is 3. 9 divided by 9 is 1. So it is 3 plus 1. You get 4 over 9. Then you get the reciprocal, which is 9 over 4. You get 2.25 microfarads. So that is the effective capacitance of this network. But now you're supposed to get the charge. So first of all, we get the total charge. The total charge Q is equals to CV. So you get C multiplied by V, which is 10 volts. You get that Q is 2.25 times 10 to the power negative 5 coulombs. But now we are supposed to get the PD across the 5 microfarads. But for us to get that, we need first of all to get the charge that is stored in this one, which is in series. And by so doing, we know that the PD across 3V will be equals to, the PD is different from here. So it will be, because this one is in series, the charge that is in here is the same as the charge that is coming from the external, or the total charge, which is 2.25 times 10 to the power negative 5. So by getting the voltage across 3 microfarads, we can be able to know the charges, or the voltage that is across these 2 parallel capacitors. So we have the PD across 3 microfarads is equals to 2.25 times 10 to the power negative 5 divided by the capacitance, which is 3 times 10 to the power negative 6. And that will give you 7.5 volts. But the total voltage is 10 volts. So it implies that the voltage across this one, and it is the same as this one, it will be 10 minus 7.5. You get that it is 2.5 volts. So the voltage across here is 2.5. The capacitance is 5 microfarads. So we can be able to get now the charge, because the charge is given by Q is equals to CV. So C is our capacitance, which is 5 microfarads, multiplied by V, which is 2.5. So you get that the charge that is across here, or the charge that is stored here, is 1.25 times 10 to the power negative 5 coulombs. Then we have question number 3. The figure below shows the arrangement of 3 capacitors, 10 microfarads, 2 microfarads, and 5 microfarads. We have it here. We have 10 microfarads, 2 microfarads, and 5 microfarads. Determine 1, the effective capacitance, and we proceed as follows. If again you look at this arrangement, 2 microfarads and 5 microfarads are in series. They are like this, they are in series. And when they are in series, they are now in parallel with 10 microfarads. So because they are in series, the capacitors in series will be 2 microfarads times 5 over 2 plus 5. You get that the effective for these two is 1.429 microfarads. But now this one is in parallel with this one, as you can see. So because it is in parallel, you just add 10. 1.429, which is this one, plus 10, you get 11.429 microfarads. That will be the effective capacitance of this network. Then part 2 of the same question, you are supposed to get the charge on 5 microfarads, this one. So we proceed as follows. The total charge is CT times V. So CT, this one, total capacitance, then multiplied by voltage, which is 20, you get that it is 2.2858 times 10 to power negative 4 coulombs. Then the charge on 10 microfarads. Remember, if you look at this one, it is in parallel. Therefore, the voltage across here is the same as the voltage of our external source. So the voltage is 20. Therefore, we can be able to get the charge. Our Q is equals to CV. So our charge for this one is 2.0 times 10 to the power negative 4 coulombs. Therefore, the charge on the 5 microfarads will be the total charge minus this one. So that will give you, when you subtract, you get that the charge that is on here will be 0.2858 times 10 to the power negative 4 coulombs. And this charge will be the same as the one that is in 2 microfarads because the two are in series. So that is the value. From there we have the assignment. Again, the assignment is testing what we have just covered. So make sure that you are able to recall. And when you recall, make sure that you do with a lot of keenness to avoid careless mistake. And also prepare for the end of topic exam. So thank you, and let us meet in another topic.